managed to connect with that, but I can use the clicker.
Good.
To drive the slide, sure.
You can also stand up if you want to.
No, it's okay with the camera. Yes. Should we start?
Okay.
Hi, everyone. Welcome to the session of the co-working group at IETF 123. I'm Marco Tiloca. My co-chairs are Jaime Jimenez and Karsten Bormann beside me. Of course, we assume people to have read or at least be familiar with the drafts, especially those in the agenda for today. We tried to do a good use of the time here for high bandwidth discussion and syncing to progress the document. And the not well applies, more details about that here. Please be familiar with those if you are not already. If you are personally aware of any IPR that relates to the document discussed here, you have to disclose that as soon as possible, or you can refrain from participating in the discussion. It's also about our code of conduct, so please be nice with each other. A few practicalities. This meeting is recorded according to the Not Well. If you are participating here in the session on site, please be sure to log in the session using Meetecho, preferably the on-site tool, to be tracked as a participant. If you still want to use the main online version of the browser, even if you are here, be sure to mute your audio and video off. And if you are on site and want to join the queue, please do that on Meetecho first, and then go to the mic. Should be a bit easier for remote participants. Try to use a headphone if you can. And if you are remote and you want a question to be relayed on the mic, just type on the chat prefixed by mic. Yeah, before we get into the actual meeting, this should be the first session with Mike fully enrolled as AD. I think that happened a few hours after the session in Bangkok. So welcome again, Mike. Thanks for the help and the review so far already. Looking forward to continuing working with you. And the series continues. Okay, this is the very packed agenda for today. So for the speakers, please really do your best to stay on time, and the chairs will do their best to be sure that happens. After this introduction, we have two slots led by Karsten, one on the correction and clarification for co-op document and the related activities around it, mostly in interim meetings and on the GitHub, but also the href document concerning resource identifiers that is in last call as we speak. Then we have Christian with co-op transport indication. He presents remotely. And back-to-back with Martine on a related topic on core DNR. Then we have Ricard with two presentations actually, squashed in a single 15-minute slot on update for keys and identifiers for OSCORE. I'll follow up with observe multicast notifications, and Christian will follow again on a partly related topic, by the way, cacheable OSCORE, a document that we have in working group adoption call at the moment. Then we have Carles with co-op over bundle protocol, and I continue with the new proposal for encrypting the partial AV in the OSCORE option. And finally, we have Torles on using or extending co-op for work happening in Anima, GRASP. Agenda bashing, and I was waiting for that, Martina.
Yeah, Christian and I actually agreed that our slots, so the co-op transport indication slot and the DNR slot should be swapped.
Yeah, so you first.
Okay.
That works, thank you. Any more bashing? All right. Going into the document status. So we had approved for publication since Bangkok Core CF reg update as a proposed standard. Procedurally very important for fixing a few issues in an IANA registry related to core, and also improving that in the process. It's with the RFC editor queue now. Thanks a lot to the authors and the group for that. That was a very important fix to do. We are following the tradition of alternating the status of documents in this working group with the status of documents related to core, but in other working groups. And considering the approved for publication status, we still have a document already approved in Bangkok, I think, in ACE that is in the RFC editor, so it should be published anytime soon. In ISG evaluation, we have quite a bunch at the moment, starting with DNS over CoAP, going on from the start in parallel with a CoAP DTLS ALPN, the first proposed standard, the second informational. They are already scheduled for a telechat beginning of August. And then we have more documents in IETF last call until the end of the month. Two are part of the GroupCon cluster, so GroupCon BIS, updating the original RFC 7390, and then OSCORE GroupCon, defining the Group OSCORE security protocol. And third, also in last call until the end of the month, href, or constraint resource identifiers, that is also in the agenda for today, and Carsten will cover. We have more in publication requested, but related and in other working groups. One is ASCII GroupCon OSCORE, related to Group OSCORE as it defines an incarnation of the OSCORE Group Manager based on the ACE framework. It's in AD evaluation, and just yesterday we received the AD review to process, actually. And there's also another related document for which publication was also requested on the same topic, really, but more on an admin interface for the group manager. More on the post-working group last call processing side in core. We could track these two. One is conditional attributes. That is in version 11 now, and it's waiting for the chairs to unlock this, and the chairs are waiting for a few more actions to be taken on the document following comments from working group last call and side topics that popped up and were also discussed in a few interim meetings as also related to core CLAR. The second one is core PubSub, pretty much in the same position, for which there's a few more things to do following the last call, including a review from Christian. Other documents in the working group, we have had, even relatively minor, some updates in three of those. They are not presented today. Core COMAI, part of the CoreCon cluster, key limits for OSCORE and attacks on CoAP. And we have also had a new working group document adopted right after Bangkok. It's in principle part also of the CoreCon cluster, and a very simple and short one. On yet other documents, as I mentioned before, there's a document we have in the agenda for today, cacheable OSCORE, that is already under working group adoption call for 2 weeks more, I think. And then there are more individual submissions that have been updated recently. 2 of them are in the agenda for today. Coordinator presented by Martine and CoAP over the bundle protocol from Carles. There's a related third one, a profile for CoAP used in space, but is not in the agenda for today. And there's a new individual submission that I sent before the cutoff. I'll cover it in a slot later today. And again, looking at other working groups, there's a bunch of ACE documents relatable to CoAP and/or OSCORE in ACE. One of them in particular has repurposed an ACE profile for PubSub to be really focused only on the CoAP PubSub architecture defined in core and not in other possible architectures for PubSub. We have also a document in SHIC updating the SHIC RVC for compressing the CoAP headers. And around that, there's a recently adopted document in SHIC trying to make SHIC even more flexible and ready to be extended as protocols for which headers are supposed to be compressed are extended. For example, CoAP with its options. And there's also a recent adopted document in Anima, and that's related to the presentation from Torles at the end of the session. Worth mentioning also another new submission in the TTT RG research group that was presented yesterday, and it uses a bunch of building blocks developed in core to provide a solution for efficient software update with secure group communication. That was a lot in terms of document. We also have some reports from the hackathon, largely from Martina, who worked a lot on DNS over co-op. Main points were the work on the amount implementation and providing AIO DNS procs for Fedora, but you can find even more details in the report that Martina gave at the hackathon on Sunday. And then Jaime also worked on the AI agent operating IoT devices over co-op. That was also part of a presentation yesterday in T2T RG. Reviews. Thanks a lot for the reviewers for providing your comments. It doesn't have to be a top to bottom in-depth review. Comments, opinions on 2 sections count very much as well. This really covers the final stages like shepherding, AD review, directory, and whatnot, and that covered a lot of documents already this round. But in a sense, it's even more appreciated to get spontaneous reviews from working group participants. We could certainly attract you from Christian, of course, and there's always a very active stream of comments and issues open on the GitHub. So please, you are very welcome to contribute to reviews document at any stage, at any depth. It helps consolidating consensus and ensure that documents have a good quality. And as a token of appreciation, again, you get a little ducky for each review you provide. I have to give some around at the end of the session. Don't run away. We scheduled already the next series of core interim meetings. We continue bi-weekly on Wednesday European afternoon, alternating with CBOR, but it's basically Wednesdays at 14 UTC. And we're going to have 4 resuming end of August until, well, essentially the cutoff for Montreal. And just to advertise a little bit in terms of cross-pollination area, Esko is going to give a presentation, Leverage Co-op for Network Management, in the Ops area meeting on Thursday after lunch. That Med organized and reached out to have presentation about co-op, to know co-op in the first place and to see how it can be useful in some network management issues and topics. So you're very welcome to attend, or worst case, check the recording if you can't. Thanks, Esko, for accepting doing this. Okay, that was all for the CHES introduction. Any more comment or question at the high level? Okay. Then we get into the presentations, and next in line is Karsten. Thanks.
Okay.
I'll try to use your laptop.
Yeah, can you just start the timer?
Yeah.
Okay, this was advertised as corrections and clarifications and href, but really it's all about URIs. When we started the work on co-op in 2009, we thought HTML we can't use, doesn't make any sense in the IoT. HTTP, probably need to do something new. But URIs, those are wonderful and we like them. And we still like them 16 years later, but maybe in a slightly different way. So one question that came up is a trick that we were using right from the start about the URI host co-op option. That essentially gives you the host component of the URI, and that has a default value. And the default value is interesting. And this is now coming up in the corrections and clarifications document, which is a document where we collect items that are issues or that are very small changes. The question is, when we did co-op over TLS, we said that setting an SNI, a server name indication, in the underlying TLS connection was influencing the default value for the URI host. Normally, the default value is the IP address of the request destination, which makes a lot of sense because that's normally where what you have in your host component. But of course, if you are using TLS, you actually know the host name that will be checked in the TLS handshake. So that's a much better default. So we put this into TLS, and this is the text that is in 8323. And it says very explicitly, for CoAP over TLS. So no other usage is actually addressed by this paragraph. Why did we do this? Well, we had enough problems getting CoAP over the TLS through, and we thought the less changes we cause in other places, the better. So we just restricted this to CoAP over TLS. But of course, it turns out now that SNI is more widely used. We wish that we had made this the default in DTLS too, but we just didn't know how to do this. I think the timer is not really running. I still have 7 minutes. Okay. Yeah, so that's where we are. And there is now an issue number 49 on the corrections and clarifications. Now, this is a weird issue because we don't need any clarification. The text is very clear, but we don't like it anymore. So how do we handle this? Oh, it's moving. Good. So how do we do this change? Well, the end result we want is pretty clear, but how do we actually update the RFC 7252 DTLS modes, the raw public key mode and the certificate mode? Now, if we just change the text to be like for DTLS to be like TLS, the question is, what does this do to existing deployments? And for new implementations, are we creating a new implementation problem? I have no idea whether it's easy for DTLS implementations on constrained devices to actually hand up the SNI that has been provided. So from a transition point of view, making this change, we have two things we have to look at. First of all, a client that is implementing the change is kind of assuming that they get the new semantics. So how is that assumption justified? That we really have to answer that question for ourselves. And on the other side, if the server makes this change, then really the client should know about that. And the client also should be able to find out whether a server that it's talking to is implementing the new or the old UI host semantics. And that is starting to get a little bit uglier than the enthusiastic previous slide. So it's really hard to do these transitions. And one idea that came up that I would like to briefly discuss here, even if we have 2 minutes for that, can we maybe couple this with a need to write a DTLS 1.3 document? Because really the text in 7252 is about DTLS 1.2. So we have to write something. It can be very short, but we have to write up how we use CoAP over DTLS 1.3. So would that be a trick by which we can smuggle in this new default for UI host? Or is that creating a new set of problems, such as thousands of deployed DTLS 1.3 nodes not doing this and so on? So if people have an opinion for that, please queue up at the mic. People don't have an opinion on this. Christian.
If we are making this about opinions or about polling who has deployed something, maybe we should also ask people who have deployed DTLS 1.2 or CoAP about whether anything in their implementations cares about the URI host, because while architecturally it makes a lot of difference, many practical implementations just ignore those things anyway. I mean, if you look at, for example, lightweight M2M, like they didn't even register or think about a scheme, let alone a URI host for all the resources, because they're just working on paths. So let's check whether that's actually an issue even for 1.2.
Okay, so what you're saying might soften the impact of change. So that's good to know if we find that out. Any other comments on this? Should we even go ahead with this or just ignore it? Let's go.
Hi, Esko Dijk. Yeah, I just wanted to think about implementations I know about that are in thread and that use co-op and DTLS. So that's all DTLS 1.2 actually. And there's no SNI used at all there. So the ones related to thread, basically the mesh networking protocol. So that would not impact that for sure. Yeah, thanks.
Thank you. Okay, so the whole thing lives at this issue 49 in the corrections and clarifications document. If you want to contribute to that, you can update the issue there, make a comment on the issue. Of course, you can also use the mailing list. But I think we will need to run this discussion for a while. Please keep it in mind. Okay, so the other form of URIs that we are working on here is CRIs. And now you may wonder, wait a minute, we just sent this to the ISG. What's going on here? Of course, during ISG processing, interesting things come up. And the first thing that comes up is that the very thing we just talked about, the special meaning the request destination address has in the translation between URIs or CRIs on one hand and co-op options on the other side, that of course also is visible in this document because it describes the method by which you translate between co-op options and CRIs. And it turns out it's not easy to get this editorially right. And what I forgot to put on this slide, there is also another issue, 38, that raises the more general question, do we actually have to rewrite this algorithm each time we need it? Well, in this case, probably because it's about CRIs and not URIs, but in other cases, maybe we should not be in a position. But then we also have to have a better way to talk about this request destination address, because yeah, that may mean something different for a different transport option. So I just wanted to mention this. Again, there is an issue out there, actually a pull request that is not yet quite ready for adoption. The IETF last call runs until Tuesday next week. So maybe we get some more items we want to work on, but that's another place where this comes up. Okay, but the real little bombshell, you may have heard about zone identifiers in IPv6 and how these break everything they touch. And of course, this has happened here as well. A long time ago, we thought we had kind of solved this. RFC 6874 defined how to include a zone identifier in a URI. And then after a while, the browser manufacturer said, you may say that, but we are not going to implement that. So that RFC is dead. And that essentially has been tracked now by the IETF by obsoleting this document. So in the future, there will be no way, until life changes again, no way to include a zone identifier in the UI. And maybe we are not that unhappy about that, because it was very useful, but also very painful in some ways. Now, this is about URIs. CRIs don't have that syntax problem. They don't use percent encoding in these places. They don't need percent encoding of percent characters and things like that. So we are probably also the people who think more about linked local addresses and how they can be used in co-op interactions. So the resolution we did as a working group was to essentially keep the zone identifiers in the CRIs. So there is a place for them. But yeah, since the situation is in flux, there are white patches on the map. So we cannot really paint the whole picture. And Mike Bishop's review said, well, yes, this situation is in flux, but the white patches don't have to be that large. So what this pull request or its predecessor did was resolve this by saying, okay, the situation is in flux on the UI side, we acknowledge that, and we do not provide a way to translate a CRI with a zone identifier into a UI. So other CRI, most other CRIs can be, most other CRI references even, can be translated into UI references, but these can't. So that's something that we just probably cannot fix. The other thing is that we have simplified and streamlined the way those zone identifiers are actually contained in CRIs. This is a change in the CDDL. It doesn't change existing representations, but it's a little bit more flexible. So you actually can slap a zone identifier on an IPv4 address. People tell me they use that. Yeah, I thought it might be easier to just make the syntax a little bit more flexible. So that's one thing where I just want to make sure that we, as a working group, are all on the same page. Now, the other thing, describing the situation, well, RFC 4007 defines zone identifiers. It's one of the worst RFCs I have encountered when I started working with the IETF. It doesn't even say what kind of text these things are. So we are just making a decision. It's UTF-8, and some Microsoft people aren't that happy about that, but I think it reflects reality that they are mostly ASCII in reality. I don't even know whether you can have a zone identifier that is not ASCII in Linux. I don't know. Yeah, so those zone identifiers, of course, continue to exist. And in the IPv6 interface, RFC 3542, is that number right? There is, for instance, a place where you find that zone identifier in a socket address. So that stuff is kind of stable, except for the bad definition of the text. But there is nothing anymore that maps this to UIs. And there is some more discussion in Dave's currently individual draft that we have referenced it just because it's good background material. Okay, so this is the description of the situation. And then result number one, the CRI specification does not define a conversion from a CRI containing a zone ID to a UI. I think I just said that. But we are keeping that functionality. And this means CRI implementations that can use that in a useful way, can use this as a way to include a zone identifier in a CRI. The underlying problem that this is not really fully defined remains. And there's one more observation here. The ISG has recently approved RFC 6991 bis, which is the set of Yang types you have predefined. And that includes an IP address with zone identifier. And we wanted to make sure we can do exactly what RFC 6991 bis does and don't get a feature gap in one direction or the others. So this is what guided the CDDL change we had. Okay, so my reason to bring this up is that we have clarified and sharpened the working group consensus that we already had. But of course, we should make sure that this is still in the interest of the working group, even if the process now is in the ISG. So if anybody has any comment on that, do it in 37 seconds or send it to the list.
Christian, you have comments in the chat. You want to relay them to the mic?
Had I wanted that, I would have prefixed them.
Had I?
Come again?
Had I wanted them relayed, I would have prefixed them with mic. Or
Okay, sorry. No, no need to relay. It's on the
Okay.
chat.
Okay, since we do seem to be on the same page,
Yeah.
Next.
Next, Martine then.
Yep. Hi, I'm Martin, and I want to talk about the discovery of network-designated OSCOL-based resolvers, or core DNR, the problem statement we wrote quite a while ago. So the goal of that was to provide service parameter definitions to bootstrap co-op security. Some example use cases are to use DNS to find a security context, use DDR or DNR to find local recursive doc resolver. This means you can find a doc resolver via DNS, neighbor discovery, or DHCP using the respective options. This may also include that you can configure an ad hoc credential for co-op servers and configure ACE details for co-op servers, or find, for example, DTLS raw public keys when you're not using WebPKI. And the problem that we stated were basically what appropriate service parameters are needed. And we gave ourselves some homework at IETF 122 to sharpen this into two possible independent main topics, how to lead a doc client to object security and how to help the doc client to find a security context. An example for where you have A but not B would be that would be ad hoc with Webpack PKI, so some like TLS like ad hoc. If you're wondering where transport security is there, we basically already included that in DNS over co-op, so we didn't address this here. But we did not address this yet in core DNR because things happened elsewhere. On the one hand side, there is a transport indication draft that Christian is talking about later, and then also there is the app profile draft that Marco talked about this morning in Lake. And so the transport indication draft defines the following service parameters already: a CRED service parameter, which provides cozy credentials, which addresses basically topic B. An ad hoc info parameter, which provides one app prof sequence or ad hoc application profile for the well-known ad hoc path, which addresses basically topic A. And it also provides OAuth hints, which provide AS request creation hints to configure ACE details addressing topic B. And yeah, and then also the question is raised, which co-op transport to use with the service parameters. And this was basically folded into ALPN. So we already had co-op and co from the RC8323 and our draft on co-op DTLS ALPN. And for the unsecured version, there's basically the same ALPNs, just in uppercase. And the Lake app profiles basically defines an ad hoc path, which can provide one or more paths beyond well-known ad hoc, and the ad hoc app profile, which provides one or more app profile sequence for each of these paths. Again, addressing topic A. And as you might have noticed, this overlaps somehow with ad hoc info, but there's already a mailing list discussion, which basically in the time between when I wrote the slides and now, they came already to a conclusion that the ad hoc info will be removed in future versions of transport indication, and we will just go with ad hoc app profiles. So what is missing? So there's this TLS-like ad hoc case for ad hoc with web PKA, but this could just be an ad hoc app profile in our opinion. Then there is how to find DTLS security contacts, which could be folded into creds. Question is, do we want that? And we can also do this with stain, the TLSA records. I think Christian will talk about this a little bit later. We'll talk a little bit about that, why it could be a better route. So our question now is, given that this was somewhat of a homework by this working group, is there still a problem that needs to be stating and that needs to be worked on by this draft?
Well, there's a person in the queue, Vishal. Go ahead, Vishal. If it's intentional to be in the queue. Maybe not. More comments or questions? So if the answer is no, is this still useful to have this content around somewhere else, maybe in transport indication?
Yeah, I'd say so as well. So yeah. So yeah, okay. Then I guess I won't continue the work on this draft.
For sure, that's useful.
Focus more work on transport indication.
Everyone, if they have an opinion on this question, please give your answer to the mailing list.
Yep. So, and then I wanted to talk about the hackathon, but you already did this, so you can see my summary of that on my slides as well in the data tracker.
Maybe we have Vishal. Never mind.
And thank you.
Thank you. Next one is Christian.
Yes, I'll basically continue with the topic that that Martin already started. Can I have control of the slides, please?
Yes.
I can't quite reach the clicker.
1 second.
I've talked about transport indication in various previous meetings and interims, so I won't go into all the aspects, but I would like to focus on one aspect that has evolved basically around the last IETF and been updated until now. That is the viewpoint of the modeling of the information that a client needs to obtain in order to complete its operations based on a URI. Just as Carsten mentioned, so maybe just briefly, so the overall mission in a very short line is we have a client and we want to allow that client to address, to obtain resources without altering the URI every time a different client needs a different scheme without coming up with new transport schemes. So how does that client find its server? Basically with URIs, but we'll take 3 different perspectives today. One is the one of using web links, which is what transport indication started out with, and which is a technology that has been available basically for since longer than CoOP has been standardized, even for constrained devices. That will also always be like shown in the top left. On the bottom left, I'll show how we can find the same information with DNS. But this document now models all the information that is found through the different resolving mechanisms in a consistent way. That is, we have any resource that is hosted on some particular origin consisting of a scheme and an authority. Sorry. And in the course of finding out how to reach that, the client will learn some properties of that origin as a whole, but it will also discover different means of reaching that origin. So the common example that we'll use throughout the while going through the parts is that some device is told to obtain a temperature from some resource T on a device called sensor 1. So that would be a link such as this one, if we ever follow that on core interfaces. And then we'll gradually answer or address harder and harder questions about that resource, about how the client can reach it. The easiest is what address do I find this? Because the client needs to do the name resolution. And the most widespread, I think, means of resolving a name through the system resolver is eventually winding up in DNS. So that's what we see on the bottom left. You might get one or more quad A records for that name. And those are then, as you see on the right, independent ways of reaching that particular resource. And because the scheme is co-op, there's always a kind of default ALPN if you're reaching an IP address. That is the co-op protocol as defined in RC 7252, which, as part of this document, now also gains an ALPN. Quite briefly, on Martin already touched on it. Earlier versions of the draft had a co-op transport parameter that worked like exactly like ALPN, but tried to not talk about transports that are not really transport security based, because ALPN is a term originating from TLS, and also the registries in the TLS registry group, but really not all the values registered there are about TLS based. So I think it's a valid simplification to use ALPNs both for the TLS and the non-TLS based protocols. The version that we can that has also been in this document for quite some time about how we can express the same information in web links is shown in the top left. It's about expressing that those origins can also serve as a proxy when trying to reach our destination sensor one. It's rather verbose on the paper, mainly because RFC 6690 link format is rather verbose and does not optimize quite well for this case. But given that core href is already being completed, I'm confident that we'll have better formats for expressing the same link information. The next piece of information is how do we reach it, not just on the IP layer, but on the transport layer. And here the information about that that resource being reachable over CORP. Oh, I'm sorry, I mixed a bit up of the example, so I'll have to explain this a bit better. If as long as it's shown on the top left, our resources URI does not change, we'll have to indicate as the part of the lookup also that there's a particular transport to be used. In this case, in the bottom left, DNS reports that the ALPN for this is co-op. In that case, that the way that's written here, that stands for co-op over TCP. So that particular resource can be reached over co-op over TCP. And the mistake in the slide is that it says C plus TCP in the URI of the origin. It should be a piece of information attached to that particular transport, because that's also visible in the top left when we look at it in link format way. That resources on co-op ://sensor1 are reachable among possibly other transports through co-op over TCP at this or that particular address. Things get more complicated when we try to introduce additional future transports that are IP-based, but that are not supposed to get a new co-op plus something scheme, because maintaining those will we have to find a way to limit how many of those we register. So if we had a co-op over quick transport, we could, like on the DNS resolution, just add this as an ALPN and resolve a co-op URI into something that can be connected to over quick. So it would say in the transport specific information on the right side, it's not just an IP address, it's an IP address that can be reached on maybe a particular port and in particular over quick. And in order to express that in a link, we'll have to use the extension points of URIs to give additional metadata about a destination that we could express as a IP literal. But if we did it as an IP literal, we couldn't extend there. So the .service.arper special use domain is introduced in this document to allow expressing a richer set of information about something that might otherwise fit into an IP literal as part of a proxy's origin. The next harder level of this is finding information about which security contexts can be used for that resource. And here, I think it's important to mention that not in every case this is something that needs to be discovered from the URI. There are deployments that will basically work like any browser works, that say there is a root store of of CAs in our system store, maybe the web PKI, and any peer we connect to needs to provide a certificate that has this matching name and that traces back through that lineage. If that is the policy in a client, great. That makes things very simple. But there can be cases where that information needs to be discovered along the path, and in DNS that can even be authenticated through DNSSEC. So any credentials that we might have that we might want to advertise to the client, so that the client will verify that the server is really providing those credentials, can be put into the CRED service parameter introduced in this document, so that the client has all the information there. Conceptually, when using TLS, this is quite similar to what happens with Dane. So if there were a Dane record for our sensor1.example.com, likewise the client could discover this. But there's a bit of unclarity about how service B records and TLSA records precisely align with, and that is something that is part of the open questions. When doing the same with web links, we'd have to take a bit of a different approach and suddenly switch around the name of the top-level resource, because we can't provide authoritative information usually through web links. So the proposed solution here is that when advertising something not by its name, but really providing all the information in the link already about the cryptographic identity, the preferred way is to express that the authority has to provide that credential, and then any information about how to reach that is purely is just as informative and just as much of a hint as is an unauthenticated DNS response. There are, of course, other topics covered in this document. I won't go through all of them because I think it's more important that we focus on the modeling of all those metadata now. But if you find anything in there that's also kind of that might be things for the discussion. And to conclude, where I want to what I need from the working group at this point in time is a check on this modeling that has happened in the last 2 revisions, and that is still not like completely consistent about where are the what kinds of metadata we have, what metadata belongs to the origin versus what metadata belongs to a particular means of reaching the server. And that is something both to check with this working group, and that I'll also solicit a review from Ben Schwartz or his colleagues who have the background on the SVCP architecture, because there are some properties in SVCP already where those questions could come up, but usually don't, because most of the time there is just things are used in a way that there's just one transport in there anyway. And of course there are bike shedding questions, but like I think those will come up organically anyway. Questions from you, Mike?
So Mike Bishop, not speaking as AD, but as Service B co-author.
Awesome.
So I don't think we have any precedent for a non-encrypted protocol being indicated by a Service B record. I don't see a reason why it wouldn't work. can have ALPN tokens, and there is already one ALPN token reserved for non-encrypted protocol, which is H2C.
Yes.
I just filed an issue for you in your draft that H2C has a helpful note in the registry that says this should never actually appear in a TLS handshake. So you probably want a similar note. But
Yeah.
I mean, conceptually, the way it works with HTTP is that if you ask for H1 or H2, then we're going to try over TCP with TLS. If you ask for H3, we're going to try over QUIC. So I think this follows a similar pattern of the ALPN token actually implies the transport, and then what actual application layer protocol you pick over that transport might vary. And in this case, you only have one. But I think conceptually this can work. It's just novel.
Thank you. Esko?
Hi, Esko Dijk here. I was looking at the timer and there's still some time left, I think. So I decided just to go for this question. It's not related to the ones on the slide here, but it looked like you had the assumption that basically this hostname part in the co-op URI, that it could be resolved with DNS as a choice. And I think we recently got some review feedback like, well, RFC 7252 is saying that it could be DNS, but it could also be something else. So is that something we need to consider? Like it
Yes.
might not be DNS there?
This list is not exhaustive. There can be, I fully agree that there can be many ways for the system resolver to perform its duties. But DNS has a very, provides a good example of what this can provide, and the model on the right side of the slide is there as to indicate that any other mechanism can just provide the same information. So, for example, especially when I'm looking at transports such as CORP over GATT, which is running over Bluetooth, there is also a mechanism for over in there that goes from having the MAC address to having all the details of how to reach the co-op endpoint in there. And just as DNS has its service bindings, the discovery process of Bluetooth will tell it like a numeric descriptor of like which particular GATT attribute that is in there, and other descriptors about which, for example, which version of co-op or something Bluetooth we are running in there, which is in a sense equivalent to the ALPN we have here. But yes, every other mechanism other than DNS can provide the same. And I think I have a bit in the document even, for example, if you're doing a lookup through the get-addr info mechanism of the Unisys, that may go through DNS, but that may also go through an etc hosts file, and that can also provide information that might not be expressible in a URI. For example, that can contain a zone identifier. It would kind of perform rather badly on discovering transports, but that's just a matter of looking at which resolution mechanisms are suitable and which need additional help, as can be provided, for example, in web links.
Okay, thanks. And now I'm out of time, so I'll stop. Thanks.
Let's continue on the mailing list then. Thank you.
Thank you, Christian and Esko. Okay, next in line should be Ricard with your presentations.
All right. Hello, everyone. Thanks for the clicker. Yeah. So I'll be presenting two drafts, starting with this key update for OSCOR draft. And just to recap what this is about, fundamentally it's about renewing the OSCOR master secret and master salt, thus deriving new sender and recipient keys. And you may want to do this for various reasons like application policies, or there's also work going on about the fact that using keys too much with AED algorithms can weaken the security properties of those algorithms. It has a number of beneficial properties, loosely inspired by the Appendix B2 of OSCOR. And basically what happens is the pairs start with CTX old, their old context, and after running kudos, they have CTX new, which is the new context with fresh keys. And we did recently a larger redesign to basically a more state machine-based approach. And just to recap a bit more, like fundamentally, this is about an exchange of two nonces, N1 and N2. And we place these nonces into an extended version of the OSCOR co-op option, which you can see there on the right. And in addition to the nonces, we also have this X byte, which holds the length of the nonce and some particular bits for optional functionality or configurable functionality. For instance, we have a forward secrecy mode and a no forward secrecy mode to allow for very constrained devices to also use kudos. And the key point there in the no forward secrecy mode, you always revert back to your bootstrap material as CTX old. And a bit about the kudos message type. So basically we have two types of kudos messages. It's pretty straightforward. One is a divergent message, which is saying that, okay, I as a pair am offering my nonce, but I have not received your nonce, meaning the other pair's nonce. We also have a convergent message saying that, okay, I'm offering my nonce and I have received your nonce. Yeah. And this is indicated by the Z bit in the X byte. So this is the state machine, and basically you have a number of states here, and like typically the path through this state machine would be quite simple, and I also have as backup slides like a flow through the state machine, but I'll skip that in the interest of time. But basically you can see here the transitions, and depending on if you're getting a convergent or divergent message, you will transition to a different state. And so what did we do for version 11? Well, we improved the security considerations, extended the discussion about the birthday paradox. And here one good point is basically that, if you generate more than 2 to the power of 32 X nonce pairs for the update of a given OSCOR security context, that's when you will want to, that's when the birthday paradox basically becomes something to consider as a feasible possibility of a collision. In the FS mode, this is pretty straightforward because like normally you would only have one nonce for each execution of kudos, and you're always updating a new context. But in the no FS mode, you actually always revert back to the bootstrap material, and thus the collisions are actually more feasible here. And because of this, we keep recommending a nonce size of 8 bytes to be on the safe side. We also did some updates to the IANA considerations. Yeah, minor things really, entries to entry, plural to singular, and saying 0 suggested instead of just 0 for the extension bit, which indicates that the OSCOR co-op option has a second byte of flag bits. We extended a bit also a section we had since before about updated protection of co-op responses. So basically what we were saying already is that if a server is using a different security context for the response compared to what was used to verify the request, this response should include the partial AV. And this is in the interest of avoiding nonce and key reuse, because otherwise you may reuse the same nonce from the request, but for a different context, and basically that can be insecure in certain situations. Now we clarify that this should also hold, that you should include the partial AV also for responses when the responses are observed notifications. We have a bit more discussion now about combining kudos with usage of the ACE profile, saying that you may want to exclude the kudos resource from access control, just so that you're sure that you can actually use the kudos procedure to update contexts. And this is similar to what's done for other kind of special type of resources. And we did some editorial improvements. The main thing though we did is one optimization for the state machine. So if you notice in the state machine, I guess I can go back to that quickly. In the top, you have actually here, that's quite like a, let's say, a complicated path that we were thinking, okay, is there any way we can avoid taking that path? Because it's by far the most complicated path in the state machine. And you can also see this here, the textual description. So we were thinking, okay, can we avoid that path in the interest of avoiding, key derivations and, repeated cryptographic operations? So we actually thought that, okay, yeah, we can avoid taking this path. And how do we do that? But the key solution is that if a pair receives a divergent message, if the peer can understand that, wait, this is the same divergent message I already acted and processed in the past, it's actually safe to stay where it is, stay in pending. It doesn't have to transition to a different state because it already processed this message. So what do we mean by an identical same message in this context? Well, what we mean specifically is that the nonce and x byte in this second just received message is exactly the same as a nonce and x byte that were present in the message that originally made you transition to pending. We have this outlined quite nicely in the draft also. But that's basically the key insight. You should compare the x byte and nonce for these two messages, message A and message B. And if they are the same, stay where you are, no need to change state. And just to elaborate a bit more, okay, what about if this message B is not saved, you already processed it and discarded it? How do you know what X and nonce was in it? Well, you can actually figure that out because the X and nonce are taken as input to build the master salt. So you can look at your current master salt to figure out what X and nonce was present in that message. So what are we going to do next? Well, we want to add also a figure of the state machine in the appendix, like an ASCII version of the figure in the previous slide. We want to have more message flow examples as appendixes. Now we have like two basically, starting kudos with a request or starting it with a response. But you can also have, maybe two requests, or especially examples when messages are lost, because that's when things get complicated, obviously. We want to align our kudos implementations. We have one in Java and we have one in C for Contiki NG. And then close a few minor issues captured in the GitHub repo. And of course, comments and reviews are very welcome.
Any comments or questions, anyone, before we move to the next item? Again, from Richard. Hearing none. Let's switch. Literally switch. 1 second.
Right, so this is the second draft I want to present, and this is about updating the OSCOR identifiers. So OSCOR has, as part of its security context, a sender and recipient ID, identifying the two pairs. And this is a method to update those. Can be initiated by either the server or the client. And the terminology we use is basically you start with a context CTX-A, you update the identifiers to derive a new context CTX-B, because the identifiers take part of the key derivation, so that when you switch identifiers, you also switch keys practically. It has a number of properties. I don't want to list them all here, but overall the goal, like why do we want to do this, is to mitigate privacy issues due to message correlation and tracking of OSCOR pairs, because these identifiers are in plain text on the wire. So even if you switch networks, an adversary may look at these identifiers to track the pairs across different networks in a simple way, I would say. So the document status, we submitted version 3 before the cutoff, and then a version 4 on Sunday with some minor improvements. So the main thing we did is actually kind of updating the design of the solution to be more aligned with kudos, kind of state machine based. And basically we now this is how we kind of list things in the draft, like defining the start of the procedure is when a peer sends a message including this recipient ID option. That's how you convey the recipient ID that you want, the new recipient ID that you want as a sending pair. You can also start the procedure obviously by the other peer sending you such a message. Now during the procedure, the first message you send should include the recipient ID option with your desired recipient ID, unless you were the one to start the procedure, because then you already offered your recipient ID to the other pair. Now we also want some acknowledgements. So basically, if a pair has received a valid message from the other pair, including the recipient ID option, it should use now this recipient ID ACK option to echo back the recipient ID the other pair sent. And after this, sending any subsequent message, you must make sure that you periodically send a message with the recipient ID option present, because messages can be lost and such. I mean, obviously, if no message is lost, this procedure will finalize very quickly. But just in the interest of making sure 100% that the other pair ends up getting your recipient ID, you will need to resend that regularly, until the procedure ends. So we define these two options also, by the way, basic options, recipient ID and recipient ID ACK, opaque options to contain the recipient IDs. Yeah. So how does the procedure end? Well, it can end in success if a pair has received and verified at least 3 messages from the other pair containing the recipient ID ACK option. This means that it's now safe to delete CTXA, meaning your starting context. That doesn't mean that you must delete it, because actually it's probably, typically it's smart to keep that, because you only want to actually transition to use CTXP upon network migration. So it's just now CTXP is valid and can be used, so it's ready for use when you have migrated to the new network. It can also end in failure. We have basically a timer that will run, and if this timer expires, the procedure is considered failed. And then you must keep track of this recipient ID to make sure that you don't reuse that again, because if you do reduce the same recipient ID with the same keying material, you end up with a nonsense key reuse. Just showing the message flow. I don't have to go through this line by line, but basically you can see here in the beginning, the client pair indicates it's desired new recipient ID. In the response, the server echoes back that recipient ID in the recipient ID ACK option, and the server also indicates its own desired recipient ID. And from then on, basically they keep echoing back the recipient ID to make sure that you have three verified messages containing the recipient ID from each pair. And then you can see also here, like when basically client has gotten 3, okay, now it's safe for the client to discard CTXA. And when the server has gotten 3, it's safe for the server to discard CTXA. And again, this doesn't mean you should discard it, because you probably want to wait to transition until network migration. And that's also another point we kind of strengthened and clarified much more now, that peers should not begin using the new identifiers on the current network prior to network migration, because then you basically you kind of lose the point of this idea, that you want to use the new identifiers only after you have migrated to the new network. So if you use the new identifiers on the old network or the old identifiers on the new network, I mean, you give it up. You basically let the adversary know that, okay, we switch IDs and here are our new IDs, and you don't get the unlinkability properties that we want. So we also added some security considerations. And this is basically saying similar things, that, like, first of all, we point out that, another way you could track peers is looking at OSCORE partial IV. So if you see, like, okay, they have partial IV 100, and then something pops up on a different network with partial IV 101, I mean, it's quite likely that's actually the same peers just transitioning to a new network. But fortunately, because we're deriving new OSCORE security context, CTXP is a brand new context with the new IDs, and that means the partial IV, the sender sequence number, resets back to 0. And obviously, there's other information that can be used to track the peers, like the network information. So, upon network migration, you would hope to switch network address and also switching the link layer address, because theoretically, otherwise, those things could be used to track the peers. What's the summary and next steps? Well, basically, we want to add more examples, also including failure cases as message flow examples, let's say more advanced examples also with lost messages and such. We want to reconsider now how this ID update procedure can be ran integrated with an execution of kudos, because that's convenient if you can do both things at once, both change master key and master secret and master salt, and change IDs. Also, we want to consider optimizations of this new design. It's a brand new design, so there could very possibly be room for optimizations. We want to implement it, and yeah, comments and reviews are welcome. So thank you all for listening.
Thank you. Any comment or question? Not for now. Follow up on the list. Thank you. And timer. Hi everyone, this is Marco speaking as an individual. This is an update of the observed multicast notifications document. As a recap, this is intended for scenarios where co-op observe is used. So you have clients essentially subscribing to the representation of a resource at the server. But here in particular, you have multiple clients all interested in observing the same resource at the same server. So instead of serving the different clients back with separate notifications for each client, the idea is for the server to serve all the clients at once, serving them notifications as multicast responses every time the representation changes. It's all about synchronizing the clients to be on the same page in terms of transport information and security information. And the server does that by replying to clients as they come with an error response that contains that transport-related and security-related information. So from a transport-related point of view, the co-op token still belongs to the group of clients, but the management of the token space got entrusted to the server. And the transport information includes typically the token to use for transferring the group notifications together with actual addressing information where those are sent. From a security point of view, well, things get aligned in a clever way through GroupoScore and its external EAD. And that has been stable for a while now. So what happened in this last version? I noted, not to self in the minutes from last meeting from Christian about considering changing the CBOR type of one parameter in the period of the informative response. It's taken now. It used to be just an unsigned integer. It's more appropriate to be tilde time, which is a short for integer or floating point number that's more aligned with the intent we wanted to have for that parameter. So numeric date, like in RFC 7519. And it's basically the time when the group observation is supposed to end. We also had some clarification notes about not limited this data item and this format exactly and only to this protocol. It's confirmed that, of course, it's in response with that content format. It's a CBOR map with those abbreviations in CBOR taken from namespace rectified by a registry that we are defining for that. But we have clarified that, well, when used in this document for this protocol, you have to follow exactly these rules for composing that object with the parameters having exactly that specialized meaning. But that doesn't exclude to reuse the media type and the object and possibly other parameters or new ones to be defined in other protocols. And now we have a case in point in the work I mentioned in the introduction of the meeting that was presented yesterday in T2TRG, where concepts from this document and, well, those parameters and that informative response are reused with slight customization. More updates, two small updates on Appendix C that has been already present for a long while. It describes a particular setup where, well, GroupoScore is used in the first place, but the server is also acting as a manager of the OSCORE group all by itself, which can be convenient in terms of optimizations. In that context, we also updated the CBOR type of another parameter in the same error informative response, exp, just to be aligned and consistent with the change we did for the ending parameter that I mentioned before, but it's really the same thing. And finally, we could take care of an annoying long-pending editor's open point on a parameter that had a technically wrong name, but had to be consistent with the latest version that we had of another document in ACE. But that document got updated, the parameter name was fixed there, we could accordingly fix the parameter here too. Now they are aligned. The biggest change is in this slide that was anticipated at the previous meeting as an open point to address, and now it's finally done. It's related very much to what Christian presented before for transport indication. Considering the work happening there, it's not true anymore that a transport can be fully understood just looking at the URI scheme. In general, you need to consider the pair URI scheme and the authority component. The authority component may not play a role if it's exactly expressing an IP literal. Otherwise, if it's a register name to be resolved, it very much plays a role. So we had to restructure some detail on how the transport used for delivering the multicast notifications is specified and understood by the clients. and the new registry that we are defining to keep things connected. And that registry actually got simplified. So the overall structure that is used to transport information is still the same. When it comes about the TP infrastructure parameter for specifying transport information, TPI server still specifies information about the server. There is a CRI with no local part again. But as I mentioned, you need to look in particular at both the scheme and the authority component to determine what transport we are talking about. More details on the fine-grained steps are really in the href document. It's not just about understanding the transport per se to properly be set to get those messages. It's also to be able to parse the rest of the error response. Based on the exact transport that is understood, you can look at the correct entry in the IANA registry that we have. For example, finding the entry co-op over UDP. In that entry, you are going to find the exact list of additional information that you are expected to find in the error response right following TPI server. That is called TPI details. And in the case of co-op over UDP, that information consists of a TPI client and TPI token. So this should be now aligned with the intent of transport indication. And as a bonus, well, that registry got also simpler in the process. Okay, as next steps, there's a few minor pending technical points that I haven't had time to discuss together among all the co-authors, and we'll have to get back to that on notes and recommendations related to avoiding leaked local addresses and on possibly setting the max age information for the first notification that is created before it is sent. We got an early review from IANA as usual for working group documents in the agenda. Granted, they're right, of course. We'll take them into account. They're minor, fortunately. And then there's the big open point for which we have a plan. We have to act on the plan. And the point is that at the last meeting in Bangkok, we have a very strong opinion in the group about gathering together all the content related to a setup with proxies as a first step to have an idea, collect it all in an appendix, and eventually strip out the content to make a separate document out of it. I went through the minutes again and collect here the most relevant input about that. The strongest voice was Matthias Kovac, but there seems to be quite strong consensus on doing that. And I didn't have time to fully act on that, but at least I made a plan. I'll act on that to produce a pull request on the GitHub, and it should be about building an appendix, very temporary, let's call it appendix out, collecting all those parts of the document that are listed here, and as a side effect, other parts of the document will be shortened here and there or even removed. They'll be about removing the appendix out of this document to make a separate document out of it, something like multicast notifications proxy. And we've done these things before here for at least 3 other documents that I could track. I have a bit of an open point of what intended status should be. If it's informational, I think that was the idea from Christian all along. But I'm also interested in the opinion from the other chairs about that. Once the PR is there, emphasizing the appendix, well, it would be about really merging the PR, removing the appendix to make another document out of it, and submit the new version of this document without any content about setups with proxies. That's all I have. Do you have an opinion on the best intended status to consider for the other document?
Well, Gast Bormann, if it doesn't have normative intent, it's informational. The purpose is to collect all the information that doesn't have normative intent, so it kind of seems obvious to do that. And just generally, as a very high-level statement, we need to make sure that the documents we do here stay below 100 pages. We have lots of stuff that people just don't pick up because they see the number of pages and decide not to read it. So informational additions are always nice, but when they take over, that's not good. So I definitely support doing this split.
Informational. Okay, we can start with that. Thanks. Any more comments or questions? I guess Mike.
Not as AD, just individual. More curiosity than anything. I see you're using a 503 status code in.
Sorry, I didn't get you.
The status code that you're using for the observe multicast.
Can you point me to the right slide when I get there?
Yeah, this one.
Here?
Yeah.
Okay.
503, which, I mean, obviously this is not HTTP, but the status codes in CoAP are strikingly similar to HTTP, and that's a server error code, and this is not really a server error. What led to using that response code as?
Well, it means service unavailable. And it's meant to say, I reject this request the way you want it to work. I have something better to offer you.
Okay.
Serving you together with the other clients in the group. So here's the information to participate in that.
Okay. So effectively, it's a redirect, but CoAP doesn't have any 3xx status codes.
And we are forbidding redirection explicitly in this document, but yes, conceptually, yes. Thanks. Okay, I think we're good. Thank you.
I'm already on.
Okay.
Cacheable OSCORE?
Right.
I think I'm next, yes. Yes, cacheable OSCORE is, can I have a slide? Thank you. Is an approach to, make OSCORE cacheable. So what is the decide feature here? CoAP works great with REST and works great with proxies because it can do all kinds of caching, retransmission, fragmentation, etc., etc. With OSCORE, we lose a bit of that ability because we can cache requests because every request is like its own. I'm getting a bit of an echo. Every request is individually encrypted. The responses are bound to the request. So caching just doesn't work over OSCORE. And this document is about things that we can do within OSCORE or in the context of OSCORE to allow this to happen. This used to sit rather idly as a document because it is built on OSCORE group communication, which is now in last call. So now we have more of a stable base to continue on it. It's already a normative reference of the document that Martin mentioned in T2TRG. It is something that I think we should make a normative reference of multicast notifications just because they work more efficiently when using cacheable OSCORE with the systematic requests. And it has already racked up a few other informative references about mechanisms that would also work better if we had some cacheability. So the thing is, OSCORE is not cacheable for a reason. And the big question is, when we do cacheability, what does it cost? Good thing, it doesn't cost a lot. There are just a few properties that we very deliberately lose compared to OSCORE. So there is no replay protection, and there is no source authentication of the request. Replay protection is, on the application level, kind of moot because this is about cacheable resources, such as cacheable requests, such as a get or a fetch. No harm in replaying. Source authentication is a bit more interesting, but we want to cache for not just one client, but a group of clients. So there has to be some minimum authentication that is associated, and that's like, and it doesn't matter if the client has more rights to the server. There are limitations to freshness because also we want to get a cached response. We don't want to have a response that is right now generated freshly by the server. And the request privacy that OSCORE affords is also reduced because, again, the proxy that is an untrusted party in all of this has to recognize which requests and responses it can match together. So what I hope is that these properties that we're losing here are really the minimal set for caching to be reasonable, and that in return, any application that wants to have this caching will be prepared to make those trade-offs because, well, it wants caching. The document has been, and I think IETF 112 was the last time this was presented. Since then has been restructured into two large sections. One is what are the implications of running OSCORE in a mode where there is no source authentication, because the request response bind is very strongly tied to the source authentication. To the point where if there is an observer who sees in group OSCORE sees a signed request by some client it knows and sees the signed response by the server, it still cannot be sure what the signed response means because the source authentication has to match even what the server sees. Based on that, we can build the deterministic requests that we need for cacheable OSCORE. There is a subsection on building such a deterministic request, and given that determinism is always a bit of a contentious topic, we are talking about best effort here. If two clients do not precisely agree on one request, the only ill effect is that the cache utilization gets worse because they have what appears to everyone else as separate requests. So no harm in not doing precisely the same thing other than efficiency suffering. Then the big challenge that is being addressed is how do we get key material that multiple parties can use to encrypt a request without suffering the ill effects of nonce reuse, which depending on the algorithm can be catastrophic in terms of cryptography. And then finally, once we have that request verified, how do we get the response bound to that request? I won't go through all the steps that are outlined here, but the one that I think matters is that when the cozy encrypt step happens, all the inputs that will be needed are prepared, they are gathered, they are hashed, and that hash is taken as an input to the group OSCORE mechanism of deriving a context key, and then that key is being used. So as long as the encryption mechanism is deterministic, and I'll come back to that, it's just one precise message that will ever be encrypted with a single key. What pieces are missing before we can complete this? I'm not sure whether we should ask the cozy group to have another column in the AED algorithms list, or whether we can just in prose describe that we need an AED algorithm that is deterministic. I'd like to have more people review this in terms of security. Bjorn was already so nice as to have a look way back at this, and I think he was kind of happy, but more review will be good. And on that section 2 about how do request and responses bind together, to me it's a bit of an open question, like does anyone else need this? Because it makes sense as a standalone thing, at least in this document as a section, but it would be helpful to see if anyone else has requirements that should be considered here. We've had a successful interoperation between Marco's Californian-based and my AIOSCORE-based implementation. So this has been brewing among the authors for quite some time. Working group adoption call is open. Let's see where this gets from there. I see Bob on the chat with a question. Is MLS possible here for shared crypto, or is it too big to objects to transmit key setup? I don't know. I haven't looked into MLS. Yeah, Bob, please.
Yeah, I have lived through too many shared key protocols over my 25 years working on this.
Bob, sorry, you're very quiet. Please get closer to me.
Sorry about that. Sorry about that. I didn't move my mic back.
I have lived through too many shared key protocols in my 25 years on this. MLS is the only one which is mathematically right, but you pay a price for that. So there are lots of things you can leverage for how to do shared keys protocol cheaply, but you pay other prices in security architecture for that. MLS is only which is mathematically solid. And you pay a price for that.
I'll have to read up on MLS because I've only skimmed it peripherally so far. What's the big danger here? That there are multiple, that the same key is being used multiple times, the same key is being derived multiple times?
MLS derives one key which is owned by multiple parties. You can then use that one key to encrypt data between multiple parties. To do that, it builds a huge Merkle tree involving all those multiple parties.
If I understand what you're saying correctly, I think we have a different situation here because the multi-party key, in this situation, being based on group OSCO, we already have a key that is shared by multiple parties that is used for encryption. It's just that usually all those parties have a mechanism of coming up with different, with a distinct set of nonces so that every party just uses one nonce in the encryption. But there is no, like, the identities of the parties as they would play a role in an MLS, in a Merkle tree. They don't participate in getting to that key. They are, that key is distributed to them. Does your comment still apply?
Okay, you have something then that maybe running down the MLS path may not bring much value. I was just was not sinking in well with you.
Yep, it was it's a valuable comment, and I'll still try to read up a bit. Thank you.
Yep.
Okay, thanks, Christian. In the interest of time, I think we should proceed. Please follow up with more comments or questions on the list. Thank you.
By the way, we are just getting slightly refreshed air conditioning again, so enjoy the noise.
Okay, hello everyone. My name is Carlos Gomez. I'm going to present the last update of the draft entitled Co-op over Bundle Protocol, BP. My co-author is Ana Calveras, and we're both from UPC. On the status of the document, the 4 previous versions of it were presented in the last 4 IETF meetings, always in core and almost always in the DTN working group, which, by the way, is the one that specifies the bundle protocol and its related ecosystem. So today I'm presenting revision 04, which aims to address feedback that was received in Bangkok and also in a core interim meeting on the topic of message aggregation, which we try to enable in this document. And we've also provided implementation status report. So this is the updated table of contents. There's a new subsection on the relationship between the payload length option, which we are currently defining in this document, and the score. There's also a new section on proxy operation and message aggregation. And also we've restructured a bit the section on proxying, and we've added a section on implementation status. So let's see the updates in the draft. First of all, section 4.3 defines the payload length option as it has been presented in previous meetings. This option indicates the co-op message payload size, and it's intended to allow message aggregation because there would be the concept of an aggregate message, which would be a concatenation of single messages that carry the payload length option. So there was some suggestion actually in Bangkok that perhaps we might consider defining a message header, specifically in this case for co-op over BP, which could provide this payload length information directly in the header. And actually we proposed something like that in the interim. However, that might work for co-op over BP, but perhaps we might also want to consider this functionality of message aggregation over other transports, like say UDP. Recall there's also a related draft which is on co-op in space, as has been mentioned before. So the feedback that we received from the interim was that perhaps the way we should follow would be defining the payload length option. And then from the discussions in the interim, we decided to change one of the characteristics of the payload length option, which would now be unsafe to forward because we understand that based on the operation of proxies, it would not be safe to forward this option by a proxy that does not understand this option. And a consequence is that this option being critical and unsafe to forward would lead to an option number that, well, the first currently available suitable option number for these characteristics would not actually be so low at the moment. I'm afraid it's number 43, perhaps not really low, okay? Anyway, then we've added a section on payload length option and OSCORE. The payload length option would be class U, that means unprotected for OSCORE. And if we have a CoAP message we want to transmit, we want to protect it with OSCORE, and we also want to add payload length information. This is the sequence of events, the steps to be followed. First, the OSCORE message would be created based on the CoAP message as an input, as specified in the base OSCORE RFC. And after that, payload length option would be inserted in the OSCORE message, and the payload size indicated by payload length option in this case would be the OSCORE message payload size. Then we've added a section on proxy operation message aggregation. We've explained here that a proxy that supports message aggregation disaggregates a received aggregate message and then proceeds normally. That means handling each individual message as in, say, the base CoAP specification. And we've also explained here that as any CoAP endpoint, a proxy may aggregate messages destined for the same endpoint. So, for example, in the figure on the slide, if client 2 wants to send a request targeting a resource at origin server X and then sends another request targeting a resource at origin server Y, the proxy may aggregate the responses that would need to be transmitted back to client 2. Or in another example, if client 2 wants to send a request targeting a resource at origin server Z and client 3 also wants to send a request targeting a resource on that same origin server, if the proxy really needs to forward the corresponding messages, then the proxy may also aggregate those. By the way, this topology shown here would match the one where the clients could be, say, on Earth. The proxy could be on a Mars orbiter, and the origin servers could be on Mars. And message aggregation would be a nice fit here, because it is not really expected that there could be end-to-end connectivity simultaneously all the time. So we've also added a section on implementation status as recommended by RFC 7942, which is intended to increase awareness of running code of the corresponding draft specifications. And as also indicated in that RFC, this section is intended to be removed before eventual publication if the document reaches that stage. So the main content is 13.1 on an implementation called Space CoAP that has been developed by UPC. The main people who have developed this are Michael Karpov and Ana Calveras, and it's based on AIO CoAP and Micro D3TN for CoAP and BP respectively. Scenarios with and without proxies are supported, and it's compliant with the previous version of the draft, which means that it includes even payload length option and message aggregation. So the level of maturity of this implementation is just research level at the moment. You can find more details about it in the draft, also in the annex at the end of this slide set, and there are also GitHub links in the draft. There's even a demo video that you may check by following the link on the slide. And we've added also a short subsection on other implementations that have been created over time of CoAP over BP. It's important to note that these implementations did not implement this particular draft because they were created before this draft even existed. But this may be useful to show that there has been some interest over time on this topic. The first implementation, TaraCoAP, was developed by a company, and also NASA was involved there, and BOAP was developed from academia. Finally, we've added some content in the security consideration section because payload length would not be actually protected by a score. So there would be some risk that perhaps an attacker might infer some features of the communication based on the payload size of the messages, at least maybe in some cases. And there could be a range of possible solutions or mitigation techniques. A radical one would be, okay, not using the payload length option, but then the benefits, the overhead decrease of message aggregation would not be possible. And perhaps low layer security can be used if available, for instance, by using BPSec. And considering the current state of the draft and also the existing running code, the authors would like to ask the chairs and the working group whether it could be a good moment for working group adoption.
Thank you, Carlos. Yeah, just relaying comment from Christian in the chat about the security considerations look even too much. They can probably even be relaxed a bit. If things were not aggregated, the lens would be just as visible.
Yeah.
Well,
yeah, but then we don't need to send the length, right?
Yeah, right. Thanks. Any comment, question? Anyone? Esko.
Hi, Esko Dijk here. Maybe just a quick question. Was it also considered to kind of bundle together other protocols like a co-op message and then another protocol and then again a co-op message, etc.?
So perhaps I didn't hear loud enough, but you mean if we are considering having headers for different underlying protocols?
Yeah, I think you can now combine multiple co-op messages this way, but not co-op and other protocol messages combined. So was that maybe also considered?
Yeah, so actually that was like our concern about trying to define a specific header for co-op over BP was that, okay, perhaps we might also want to support the same functionality over UDP or other transports. So that's why, at least for the moment, and that's the feedback we received from the interim, there was not like feedback against on the list. We continue to follow this approach of defining a new option, the payload length option.
Okay, yep.
Thank you.
Thanks. So yeah, this work came up multiple times, was discussed with the comments and implementations, and there was also a little bit of sync between the core chairs and the DTN chairs, agreeing pretty much that yeah, the right home for this work would be core with DTN kept in the loop, of course. So usual ritual questions, how many people have read the last version of the draft? Authors excluded. Okay, how many people have read any version of the draft? Better already. Well, 5+. Okay, I'm going to ask a question in the show of hands, just to feel the temperature of the group, not of the room. I can feel it. Let's give it 30 seconds or so. Yeah, the question is, do you think that core should adopt draft Gomez core co-op BP as a working group document? Give it 1, give it 2, give it 3. So for the note takers, it's 12 yes, 0 no, 11 opinions. So I think we can start the call for adoption on the list, and we follow up for there. Thank you, Carlos.
Thank you.
Thanks a lot. Okay, and next should be. Oh. Give myself 9 minutes. Again, Mark again as an individual. This is a new individual submission from me and John on possibly encrypting the partial AV in the OSCAR option when using OSCAR or group OSCAR. Why this? Well, when using OSCAR, messages protected with OSCAR or group OSCAR in groups for what is worth, including OSCAR option. The OSCAR option transports the sender sequence number of the sender peer, always in the requests. In some cases, it's a must also for responses, although it can be actually omitted in most cases. And the OSCAR option in itself, of course, is not protected or encrypted in particular because it has to be visible by the message recipient to process the incoming message. And well, among that, you have the partial AV or sender sequence number information that is essentially exposed. And that can be used for a number of things, including tracking nodes that move across different network paths. And I was educated recently and made aware that that kind of exposed information growing with that pattern can be quite useful in profiling and categorizing traffics. There's actually research work going on for that. So you may want to discourage that behavior, making the growth pattern unpredictable from an external observer. Now, the idea of protecting and encrypting the partial AV was mentioned before in an old GitHub issue in the repo of the OSCAR draft after OSCAR became RFC. The conclusion was a bit open in a sense. It was a possible future update to consider. Whatever was chosen to be done about that, the solution had to be simple and lightweight, and probably it was not useful if nothing at all could be done about the peer identifiers included as KIDs in the option, in the sense of protecting those or changing those. And well, before we also saw a presentation of ongoing work about updating the identifiers. So that's why we thought of revisiting this and contributing with, well, a formal update, at least as a proposal of the OSCAR RFC, for encrypted partial AV in the OSCAR option, of course, in a way that the protocol can still work and the message can still be eventually fully decrypted and verified by the recipient. We think it is simple and lightweight. It doesn't have any in-band signaling about what is happening in the message, and can be seamlessly used for both OSCAR and group OSCAR. It's really intended to be an add-on, so it is optional to use, and it's not about negotiation or in-band signaling or its use. It is a property of the security context, just like the security algorithm used to protect the messages. It's something that has to be understood and agreed and established at the point in time when the context was established. And by default is not used to ensure retrocompatibility. But if it is used as part of the setting in the security context, that every message that includes the partial AV will convey the encrypted partial AV according to this method. And at a high level, the rationale is encrypting as much as possible per se, because we believe it's good, and in practice can counteract tracking attacks and traffic profiling attacks. So on the mechanics, it's about deriving once and for all one additional key to store in the security context. It's derived just like other keys with the same HKDF construction, essentially changing some information in the info field of the key derivation. You can find the details here and even more in the draft. So you have this key, this PIV encryption key. Then what? Once you have prepared your message, you have encrypted it with OSCAR. Of course, you start with the plain partial AV, not encrypted yet. You are supposed to collect a sample of bytes from the protected payload, of the protected message. And that's at the very least 9 bytes. That's the case where you start from a message without payload and without options that have to be encrypted. The result would be at the very least 1 + 8 bytes, 1 for the encrypted rest code, 1 for the 8-byte integrity tag. Or you may have more. You have at least 9. Thing is, you take a sample and you take the minimum between the size of the payload and 16. Then you have to compose an actual input, and if your sample is less than 16 bytes, you pad it with zeros. If it's 16 bytes, you're done. The sample is your input. So now you have your input. It's about encrypting it using the key I mentioned in the previous slide with an unauthenticated and very simple cipher, AES ECB, essentially. The result is a 16-byte stream. Well, considering you're playing partial IV of Q bytes in size, XOR it with the first Q bytes of your key stream. The result is the encrypted partial IV, and we'll use it to replace the plain partial IV in the message. The recipient just does the process in reverse to recover the plain partial IV when the message is received. There's a few considerations already in the draft. Operational, yes, some information can leak if you have visible the transition from 1 to 2 bytes or 2 to 3 bytes in size of the plain or encrypted partial IV. That can be a leaking point. And right now we are recommending that unless it's clear in advance that the sender of messages with partial IV is not going to send more than 256 messages, then you should actually start in your security context with the sender sequence number of 3 bytes in size, because it's very unlikely to experience a transition from 3 to 4 anyway in any reasonable short time. And this can at least suffocate that possible leakage vector. On the security side, cryptographically speaking, this is for sure robust against passive adversaries. An active adversary has a bit more leeway and can leverage to some extent some side channel attacks on the recipient, possibly triggering some actions of the recipient. Because of the way OSCAR works, it takes care of replay check first, and if a replay is detected, the message is just rejected. It doesn't continue with decrypting. So there's no constant time insurance here. In terms of privacy, it helps against possible tracking attacks. Taken in isolation is probably not sufficient. It has to be combined with other techniques, meaning changing other identifying information. For example, OSCAR IDs, like presented in the previous presentation, or even addresses at different layers. On means to coordinate, that's fundamentally out of scope. It's about how you establish the security context. Still, we want to do, is not in draft yet, include at least a list of usual suspects that can be used to do that, and that are already around in the core or race working group or lake, and we plan to add in the next revision, but placeholders are already in the draft. And that's, in fact, the main next point for the next iteration. That's all we have for now. Questions, comments? Thanks.
Thank you. I'll try to make this quick. You mentioned that basically encrypting the PIV only makes sense if the sender ID is changed. And you point out that, yes, there is a means of changing the ID, but then again, once that ID changes, the counter is reset to 0. And while that ID doesn't change, isn't it rather pointless to encrypt the PIV as long as that ID stays the same?
I don't know for sure. You may want to hide even the fact that starts again from 0, exactly in that message you send.
But just about the attacker sees that partial ID, that key ID has not been used before. So, and hiding the fact that you start from 0 can be done more easily.
Problem is what you do until you change network segment and you do restart from 0. You still want to hide as much as possible, ideally.
Okay, I think we ran out of time. I just have a very, very high-level observation. I've spent some part of the last 5 years watching the TLS working group ratcheting up their privacy requirements and first inventing ESNI, defining a protocol for that, deploying this worldwide, and then throwing it away because they forgot some privacy considerations and developed ECH. And that is now finally done at this point in time. And I think we should really be careful to avoid doing the same thing. So if we have additional privacy requirements, we really should be looking for what are they? Are there other things that leak data that we don't want to leak and so on? And do that analysis before tying down the details of the protocol. But it's good to know that we have a way to do this, so that it doesn't make it worthless. I just think we should not go ahead before we understand the privacy requirements.
Without changing OSCO radically, that I don't mean to, it's hard to obfuscate more.
Well,
this is already stretched.
is changing TLS really
that's another story.
So yeah, we still have one
Yes,
person on the list. Turles, can you come up for your slot?
Thank you.
Okay.
So thank you very much for the time. So this is about work that we're planning to do in Anima, where we are trying to do something that gets into the realm of co-op. And so that's why I wanted to make sure that we do understand the options that co-op would like to be, in support of. So let me give a background for that. This is the protocol is called GRASP, RFC 8995. That was a new protocol that we developed to simplify the development of in-network automation software, not to replace HTTP or co-op, but to amend if and where the new functionality we put into GRASP would be useful in new designs, right? So you do an old design, you already have a protocol. It's typically not that you're going to change the protocol. You do a new design, you compare the protocols that you have, and if there is a function that only the new protocol provides, well, you may want to use it anyhow, right? So kind of with an operational group, not a normally a protocol spec group. So it was all kind of just extend the dog food that we have in the IETF that current solutions don't do. So GRASP uses CBOR encoding, simple header definition, really almost nothing do. Header doesn't specify transport or security, so all the applications of that have to specify what transport to use. So for example, in a managed plane solution called RFC 89994, it is basically on top of TLS and TCP, reliable messaging, hop by hop, and security as well. So what, let's say, are the unique features that GRASP gives compared to HTTP or co-op? Well, first of all, it doesn't bring the whole layer of request reply URLs and all that framework with it. You can put it in if you want to, but CBOR is trying to be much less specifying that higher level of how to define request and reply. It wants to stick as much as possible on the message level and just, demultiplexing different type of applications. So the one important unicast functionality that we have is a reliable back and forth exchange that can form a multi-exchange transaction. Whereas if I'm not mistaken, HTTP and co-op typically always have a reliable request reply, you get, post, whatever these are. It's always back and forth, but not more. So for one of the examples that I always like to bring is that you incrementally, for example, do, well, let me do this configuration line on the router. It comes okay back. Let me do this configuration line on the router. Okay, back. Let me do the fourth thing. Oh no, that doesn't work. Well, then sorry, the whole thing has failed. You finish the whole exchange with a fail, and that means none of the prior commands were applied, right? So that is the compound semantic that synchronization feature that we have has. The second big feature that we're having is service announcement, discovery, and flooding of information through hop-by-hop agents of GRASP that are doing hop-by-hop, and I think most useful then reliable connections. And I'm originally coming from too many decades with multicast, so I know all the pains of trying to do, reliable flooding of information with multicast, the reliable multicast protocols, multicast in the network. So it's a much easier thing to have on every router, a small agent that does TCP connections to disseminate, to flood messages, and that's what we have in GRASP. So now we want to kind of build more agents, and we're kind of having defined almost everything else in Anima also to be available for constrained environments, including using co-op for some of the protocols, but we haven't done this for this GRASP protocol. And so that's why we're trying to figure out what's the best way to do this, leveraging what is, what we can get from CoAP, and that is basically where the questions come in. So the option one would be we take GRASP as it is right now, and we're just trying to extract the reliable message mechanism, not the packet format of CoAP, right? So in terms of how our message is made reliable, the retransmission timers, and all the other pragmatic things that are in there, it's not very nicely separated out as a module that CoAP has meant to export, but maybe that's a feasible option to use. The second one is to say, well, so this hop-by-hop multicasting and the multi-exchange reliable messages, those could be new CoAP message types, extensions to CoAP, right? So, but that of course would mean then we would have to specify them as extensions to CoAP. And then the option, the third option is we just try to stay on top of CoAP just as an application, but I think we're losing a good amount of efficiency in there, right? We're going on top of that whole URL mechanism. I see in other discussions about, the overhead of the URL in the messages, and also we would have to do an application layer based off the multi-exchange, and we're losing the buffer savings in the multicast, for example, right? If we put it inside the CoAP layer, it's very easy to say that the reliable transport mechanism shares a single buffer. It sends out to multiple receivers and can give up the buffer as soon as all the receivers have given acknowledgement for that, right? So anyhow, so obviously the option 3, we cannot figure out how to leverage pieces of CoAP or extend CoAP. We can do ourselves as just any other application. Unfortunately, we've already seen some examples from the industry where we're really wondering why the heck have they used CoAP, right? They're almost using nothing beyond UDP. So, and of course, it would be lovely if we don't end up doing that. So yeah, I would love pretty much feedback on this option 1 and option 2 in terms of what CoAP feels about those as a group. It was way too much, way too early, but I'll remember all your faces, and if I see you in the hallways, no, but please, it would be lovely to get some thoughts about that. I think you have done some extensions yourselves.
Oh, we have a question. Yes. Christian.
So I think the most useful input I could provide on option 3, but as you're specifically asking about 2, let me clarify. You said new message types. Do you mean like extending con, non, and RST, because they are like the 2 bits are already full? That's a 2-bit field that has values from 0 up to
method codes. Yes, method codes. Yes.
Method codes. Okay.
Yes, method codes. Sorry.
Method codes.
Mm-hmm.
Then I don't have a good answer. I mean, yes, 3 is like unused so far, but I don't know what the criteria there are.
Yeah, I think you have, what is it, 8 bits or so? And I think I've seen at least one RFC extending that, adding more. But of course, I think the additional method codes that you had, they were come from the core, the core working group requirements themselves. So this is kind of an outside community coming in. So I was wondering, right, kind of how important for the working group itself do you feel, method code extensions to be, or to accept them, right? So you own the registry for them, right?
I don't know about, like, those haven't been touched in any time that I can remember. On option 1, if you want to extract the reliability mechanism and not like the rest of it, I'd guess that like altering the version field of CoAP would give you like some space that you can work in, while still having the rest of the header intact. I mean, but that's
sorry.
Basically, if you want to take option 1, I think that's like that's technically a bit like copying out a bit of like the parts of CoAP that you want. Nothing about it would be CoAP, but it's like there are tools that you already use, and there's experience that you can build on. I think that would work possibly with a different version field.
I'm so sorry, but I have a total hard time to understand you with this crappy microphone system. So let me please take that to the list if we can. Then I understand it. I'm so sorry.
Yeah, I think
sorry for that.
You have stirred the pot sufficiently that we should now be able to do a good mailing list discussion.
Yeah.
Thank you.
Thank you.
And for discussion at length, this is also a good topic for an interim meeting. So Torles, if you want to prepare something more extensive, let's take it there. Okay, we are now 4 minutes out of time. Sorry about that. Thank you all for your participation and contribution. Enjoy the rest of the week. See you.
Marco, if you could stay on for just a brief moment. Torles mentioned audio issues. Are those on my side? Is there anything? How do I sound on your side?
Yeah, I think there's a lot of reverb.
Yeah, I got the same, but this is like the same first time that I get any feedback through from the room.
I understood mostly. It got forced now in the end, honestly.
Okay.
Yeah.
I'll just check the recordings and see what things were like.
No worries. Thank you, Christian.
Thank you.
It's very hard to understand. It depends on the person listening and talking as well. I also have the same with Ecker. If he says something, I cannot understand anything.
Yeah, you have to switch to the YouTube video and turn it to 0.5
yeah, right.
times
Yeah,
speed.